Thanks for tuning in to the Oxygen Alliance YouTube channel, where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell. Hello everyone, and thank you for tuning in to week 23 of the Oxygen Concentrator Talk, brought to you by the Oxygen Alliance. I am joined by my colleague Mteto Sinjani, along with our usual technician from OpenO2 and Sunrise. So for those of you that may not be aware, the Concentrator Talk is a virtual meeting that the Oxygen Alliance hosts every Thursday from 2 to 3 p.m. And this is where we discuss the different aspects of oxygen concentrator assessment, use, and maintenance. So if you have any issues with an oxygen concentrator that you'd like us to help you out with, you can always send questions to us either during the call, or you can send them to us in advance so that our technicians get enough time to have a look at them. So joining me on the call on the technicians panel, we have Paulina Mohosho and Masofa Mojaji joining us from Johannesburg, South Africa. We have Kowinda Singh, who is joining us from Chandigarh, India. And we have Chimwemwe TSC, Efa Solomoni, and Linda Mishoni joining us from Lilongwe, Malawi. So in case you have a question that you would like to ask during the call, you can always come off mute, or you can just raise your hand and then you can ask the question. So we'll also have a topic of interest, as we normally do. So be on the lookout for that one as well. So now to dive into our questions for today. So our first question says, I was working on a DeVilbiss 515 oxygen concentrator, which is producing 82% purity after servicing its compressor and refilling its sieve beds with new zeolite. After troubleshooting, I discovered that the one-way valve between the flow meter outlet and the patient's outlet was leaking. I removed the valve and just connected the pipe directly, and the performance improved to 94.5%. My question is it okay to use the concentrator without having the one-way valve? For I do not have any replacements. So I will ask Efa to respond to this one.
Thank you, Maui. One-way valves found in oxygen concentrators allow air to flow through them in one direction. This prevents backflow of air when there is back pressure buildup in the system. As we all know, oxygen concentrators have dehumidifier bottles that contain distilled water. This distilled water is used to moisturize the air coming out of the oxygen concentrator before the air is administered to the patient. In some cases, the water flows through the air pipes into the concentrator due to back pressure that is created when the concentrator is switched off. Sometimes the water will flow into the concentrator if you exceed the maximum limit in the humidifier bottle when filling it. So the one-way valve in the oxygen concentrator is used to prevent this water from flowing through the product tank or even the sieve beds of the concentrator. To answer your question, yes, it is okay to use the concentrator without the one-way valve. I've seen a couple of oxygen concentrator models that do not have one-way valves in them, but it works well if the concentrator is being used without a humidifier bottle. But if you are using a humidifier bottle, always make sure that you fill up the humidifier bottle to the right limit, and then if necessary, add a one-way valve to avoid the water getting into the concentrator pipes. Thank you, Mwai.
Thank you very much, Efa, for the answer. I hope that was clear. But in case we have some questions, we are always welcome to ask. Or if we have some additional comments that we'd like to make, it's also important to make those additional comments. All right, seems we do not have any comments there. So we'll be moving on to our next question now. So our next question says, I have a patient that says that her OxyPure machine does not alarm when power goes off during load shedding. What could be the cause? So I will ask Paulina to take this one.
Thank you, Mwabi. Oxygen concentrators are designed to give an audible alarm to the user when there is a power supply cut. This is added as a safety feature for patients. This is just to ensure that patients are aware of the power cut, so they switch to an alternative oxygen supply, or they can check what's causing the power cut if there is no load shedding in the area. There are a few reasons why the machine is not alarming. The problem can be with the on and off switch. The switch works like a normally open, normally closed relay. When the switch is in an on position, only the power supply side is on closed position and the alarm side is on an open position. Immediately there is a power cut, the open position becomes closed and the alarm goes off. In some instances, the switch might be faulty on the normally open, which does not close when the power cuts. You will need to replace the on and off switch to solve the problem. It could also be the problem with the alarm buzzer on the PC board or the alarm battery. In this case, you would need to replace the faulty component on the PC board or replace the PC board if you do not have the faulty components. If the above did not solve the problem, then you would need to replace the alarm wire. Thank you, Mwabi.
Thank you very much, Paulina, for that explanation. I hope that helped to fix your problem. In case we have some questions or comments from the audience or the other technicians, we are always free to make those additional comments. All right, no comments, so we'll be moving on with our questions. So our next question says, the valve block of an Airsep intensity 10 was brought to our maintenance workshop, was discovered to be faulty. After assessment, only one valve of the 4 valves is damaged. I have a spare equalizer valve from an Airsep intensity 10 that we scavenged for parts. Is it okay if I use the coil from this equalizer valve to replace the damaged coil on the valve block? So I will ask Chimwemwe to answer this one.
Thank you, Maui. The valves for Airsep intensity 10 are solenoid valves. So by construction, a solenoid valve has a coil. The coil of an equalizer valve has a higher resistance than the coils of other valves on the valve block. For instance, with the 230 volts models of intensity 10, the resistance of the equalizer valve is 4,200 ohms, and the resistances of the valves on the valve block is 3,200 ohms. What this means is that supplied with the same voltage, which is 200 volts DC direct current, the equalizer valve draws less current. It is also important to know that the equalizer valve stays on for less time compared to the feed and waste valves on the valve block. So what might happen when you replace the valve block coil with the equalizer coil? The equalizer coil now on the valve block will now heat up more than the other valves on the valve block, and eventually will start to underperform and affect the performance of the concentrator after running for some time. So it is good practice to always replace parts with the original spare parts or required spare parts, as that will not affect the performance in the long run. Thank you, Maui.
Thank you very much, Chimwemwe, for that explanation. I hope that will help to solve your problem. So we have a poll at the end of this question. So once it pops up, please make sure you respond to it. So MT, you should please launch that poll.
Yeah, sure, Maui, thanks. Let me do that. So I'm gonna launch the first poll. So it's asking, did you know that the equalizer and valves on the valve block have different resistance? So just to put in a comment on this is that, honestly, for me, I've tried doing this, like taking the equalizer valve and then swapping it on the valve block. They actually physically fit when you try and interchange them, but as what Chimze said, over time, because it's supposed to draw less current, you get to get low purity on the oxygen concentrator because it starts underperforming. Yeah. So Maui, the votes are in. So it seems like this is like, oh, it's actually, I have got 3 yeses and 2 no's now. Yeah, I'm gonna end the poll.
Great, thank you very much, Mteto. So now we'll now move on to our next question of the session. So the question says, I was working on a DeVille-based 515 that was illuminating a red service required light on its front panel, and the light was being accompanied by an audible beeping alarm. I changed the sieve beds and serviced the compressor. The purity went up to 95.6, but after running for about 7 minutes, the alarm started beeping again. What could be the problem and how can I solve it? So Linda, if you would please answer this one.
Thank you, Maui. So for the beeping audible alarm due to low oxygen purity get activated when the concentrator is producing the oxygen purity of less than 60%. Since you have replaced the sieve beds and serviced the compressed purity is as required, then the problem is with the sensor. If you have another concentrator of the same model, try swapping around the concentrator control boards and see if the concentrator will work with the other board. So in DevOps 515, the oxygen sensor is usually soldered to the control board and might be hard to acquire it separately. So you just need to change the whole control board whenever the oxygen sensor is faulty. As you can see in the graphics, those are the 2 oxygen sensors which are found on the control boards. Yeah, thank you, Maui.
Thank you very much, Linda. Tedo, I don't know if it was just me or she was breaking up at some point. I wasn't able to hear some of the bits.
Yeah, so I think she was breaking up. I guess it's a network issue now.
Yeah, I guess. All right, but if we have some further questions on this, we can ask so that she can make those clarifications. All right, so seems no questions there. So we'll be moving on with our questions. And the next question says, while doing preventative maintenance on a DeVille-based 515, I noticed that I had reversed the direction of a micro disc bacteria filter. I just wanted to know what the effects of reversing the bacteria filter are. So I will ask Chimwemwe to answer this one.
Thanks again, Maui. So bacteria filters use a process known as microfiltration to filter disease-causing microorganisms. Microfiltration is a separation technique for removing micro-sized particles like bacteria, yeast cells, colloids, and smoke particles from suspensions or other gases. The process uses membrane filters with pores in the approximate size of 0.1 to 10 micrometer, which are permeable to fluids but retain the particles, thus causing separation. Microfiltration membrane can have either an isotropic or asymmetric pore structure. Asymmetric membranes are used with skin side facing the feed, that's the inlet, to minimize surface fouling. So surface fouling can be easily defined as the accumulation of unwanted materials on the solid surfaces. So the in and out might mean that the type of bacterial filter you used has a symmetric membrane to prevent surface fouling. So remember to place them in direction of flow as indicated in the side of the bacteria filter. Thank you, Mal.
Thank you very much, Chimwemwe, for that response. I hope that was clear for everyone else, but if we have some questions or further comments that we would like to make, we are always free to make those comments. So we have another poll at the end of this question as well. So Cheto, please launch that one.
All right, let me do that. So our second poll says, did you know that some bacteria filters have an inlet and outlet? So just leave it for some time so that people can respond to that. So sometimes when you try and work with these bacteria filters is that it's not visible. So you need to like have a close look just to identify if it has like the inlet and the outlet. Yeah. So now the votes are in. So all 4 yeses. Oh, no. I have 1 no now. Somebody just voted. So I will end the poll now.
Okay, thank you very much, Mteto. So it's a good thing that most people know about this one. So moving on to our next question for today. So the question says, when I was carrying out a preventative maintenance in the children's ward, I came across this oxygen concentrator which was working perfectly. The oxygen purity that this concentrator was producing was within the recommended range, but the light emitting diode for low purity was illuminating. Any idea why the LED was illuminating? So I will ask Linda to respond to this question.
Thank you, Maui. In most oxygen concentrators, the oxygen purity is monitored using an oxygen sensor connected to the control board that interprets the electrical signals from the sensor as either low or normal oxygen purity. So if the sensor is faulty or isn't well connected to the board, then weak signals or no signal will be sent to the control board. And this will lead to wrong interpretation of the oxygen purity in the system. And because of this, the LED for low purity will keep on illuminating despite having normal oxygen purity levels. So to solve the problem, you have to trace the connections between the oxygen sensor and the control board and check for continuity using a multimeter, and also inspect for any visible disconnection along the traces or wires to the sensor. If there is disconnection, take the right step to connect the circuit, and this can be done by soldering the sensor on the board if the connection is through soldering, securing the sensor through plug-in if plug-in connectors are used, and also replacing cables if the connection between the sensor and the board is through cables. If after fixing the disconnections but the LED still illuminates, then the sensor can be faulty. You should remove it and replace with the working sensor. If the LED turns off with the new sensor in place, then the problem was with the sensor, so you have to replace it. So in the graphics, those are the 2 sensors that are used, oxygen sensors that are used in concentrators, and the other image is just showing the low oxygen purity indicator on different concentrator models. Thank you, Maui.
Thank you very much, Linda, for that explanation. I hope that was clear for all of us. But in case we have some questions, we are always free to ask those questions. So we also prepared another poll at the end of this question. So Mteto, please launch that poll.
All right, let me do that, Maui. So this is actually our last poll of the day. So the poll is saying that, have you ever encountered an oxygen concentrator with its LED for low oxygen purity illuminating, even when the concentrator is producing the recommended oxygen purity level? So I think one thing I just wanted to point out as well is that as much as these oxygen sensors look different, like in terms of design, they actually work in a similar way. But it's also important to note that you can't just swap these oxygen sensors. You need to find the right model so that it works for you. Yeah, they might look all ultrasonic, but the way they communicate might be different. Yeah, so the votes are in Maui. So it seems like this is a common thing. So I have 4 votes for yes and 1 no.
Okay, great. Thank you very much, Mteto, for that. So we'll now take a short break from our normal questions, and then we'll jump on to our topic of interest for today. So today we'll be talking about post-flow, and Kowinda is going to take us through that explanation. So over to you, Kowinda.
Thanks, Moavi. So today we will be talking about pulse mode used in the portable oxygen concentrators, little different from the continuous flow used in the stationary oxygen concentrators. So the working principle of both that is same, that is pressure swing adsorption. So no difference in the principle of working. Nearly all the components inside the machine that are also same. Nearly 1 or 2 extra parts which are mounted on the PCB board, maybe the gas sensor or the oxygen conserving device that is instead of the that oxygen sensor. So that is manipulated on the PCB. So talking about the pulse mode goes by the many names as pulse flow, on demand, intermittent flow, oxygen conserving device, or an puffer. So actually, a pulse flow puffs or pulses oxygen into patient's nose through cannula with each breath. So whenever the patient triggers or initiates a breath, then it delivers the breath. This means oxygen is delivered only during the inhalation phase, and the device stores the oxygen when patient exhales. If the breathing rate increases or decreases, the POC will adjust the pulse size and the delivery frequency of the breath to maintain the real flow rate. So, for an example, to understand the difference between pulse and continuous mode, moreover, we can understand pulse mode as the best described as drinking water with a straw. So the delivery is more controlled and individualized as per the need of the patient. And on the other side, continuous flow machine, we can say like drinking water out of a water fountain. Delivery is less controlled. It delivers the oxygen even when the patient is exhaling or in the uh, phase of not breathing in. So now, first we will talk some differences between the continuous and the pulse mode. So the parts inside the pulse mode oxygen concentrator, they are much smaller than the continuous flow machine. So it is much lightweight than the continuous flow machine. So please move on to slide 1, please. So pulse mode machine are having built-in breath sensor. So you can see on the PCB, this is a Inogen 1G5 POC PCB. So that is marked on the PCB, that is the breath sensor. So whenever the patient triggers or descends, this breath sensor senses the breath. So it needs nearly 0.12 kilopascals of negative pressure to be generated by the patient to initiate a breath. So it detects the breath, and the oxygen conserving device, it is implanted with that only. So it is internally connected to each other. So then the oxygen conserving device deliver the required dose to the patient as per the settings. So these machines can be operated on multiple supplies. For the stationary machines, they can operate only on the AC supply. So these machines can be operated on AC supply also from 100 to 240 volt AC. So can be used universally, or they can be used inside the car to that cigarette lighter point charge or the charging point. So that can charge the battery from there also and can be operated from that. And they have also the maybe inbuilt battery or the detachable battery with that, so that can be operated anyway. So size and weight is much lesser than the stationary machine. Nearly, if we can say, this stationary oxygen concentrator weighs nearly 15 kg for 5 liters. So these machines, portable oxygen concentrators, their weight starts from nearly 800 grams to 8.5 kg. So much smaller than the continuous flow machines. Now please move on to the next slide. So this is basis on the pulse dose oxygen devices algorithms. So we can see in the graphics that this is a continuous flow machine indicated by the green line. So the machine is continuously delivering the oxygen, but the use of oxygen by the patient, that is only during the inhale phase, when the patient triggers in the pulse mode, or then only it is the flow is come into use. So the other phase, we can say, the during the exhaling phase, the oxygen delivered by the machine is not utilized by the patient, or we can say it is nearly wasted. So that is not utilized. So now come on to the next slide, please. So these are the assumptions. For example, the patient is taking 20 breaths per minute. So 20 per breath minutes. That one breath timing will be 3 seconds, because 1 minute can have 60 seconds. So 20 into 3, that is 60. So 3 seconds for each breath. So that it is so normal the breathing pattern of human beings, that is 1:2. So means 1 second for inhaling, then 2 seconds are for the exhaling phase. So double the time is taken by the patient to exhale than to the inhaling phase. So that means 1 second for inhaling and 2 for exhaling. Now we will see if the patient is using a continuous flow machine at the rate of 2 liters per minute. So that is a continuous source machine. So the 2 liters means 2000 milliliters. So now 1 second for the inhaling and 2 seconds for exhaling. That means only 1/3 portion of the oxygen is utilized during the inhale by the patient, and else is not utilized. So we can divide 2000 ml by 3. So that comes nearly 666 ml. So 666 is utilized during the inhaling phase, because 2 seconds it is wasting now. So else is wasted or not utilized by the patient. So now 666 ml is inhaled in 20 breaths, as it is written now. So we will divide 666 ml by 20 to calculate the per breath volume. So it comes nearly 33 ml per breath. 33 ml per breath is inhaled by the patient. So next slide, please. So now, from the total inhaling of any human being or patient, we can say the 1/3 portion of the total is the anatomical dead space. That is shown on the graphics. So out of the 33 ml in one breath, 1/3 portion is the anatomical dead space. We can say out of the total inhaling, the amount of air or oxygen inhaled by the patient, which enters the lungs, only takes part in the gas exchange. And the other part which stays in the anatomical dead space, that is the nose cavity, pharynx, larynx, trachea. So that part does not take part in the gas exchange. So that is during the continuous flow machine, because it is continuously flowing the oxygen to the patient. So that part also does not take part in the gas exchange. So we can say that is 1/3 portion. So we deduct the 1/3 portion from that inhaled 33 ml of oxygen. So that comes 33 minus 11. So that is 22 ml is utilized by the patient uh, uh, during a continuous flow machine. Now we all know the purity of the oxygen delivered by the oxygen machine is not 100%, so it is nearly 90%. So it also contains some impurities. So that we have to calculate. So 22 into 0.90 is multiplied. So that comes nearly 19 ml of oxygen is utilized by the patient using a continuous flow oxygen concentrator, right? So now we will compare that to the pulse mode machine. So I am taking the data of a Inogen 1 G5 or G3 or maybe G4 also. So it delivers nearly 420 ml of oxygen at the same setting of 2. So it contains maybe Inogen G4 has 3 settings, 1, 2, 3, and the maximum flow is 630 ml. And in case of Inogen G3, it has 5 settings, so maximum flow is 1050 ml. And for Inogen 1 G5, the maximum flow is 1260 ml. So we will calculate at setting 2. So it delivers nearly 420 ml of oxygen at the setting of 2 per minute. So that is a per minute delivery dose machine. So it is actually divided into the breaths taken by the patient. So in this case, it is not delivering the oxygen during the exhalation phase. So no case of it. So it also delivers the oxygen during the first 60% of the inhaling phase only. That means it is not delivering. It is not consuming in the dead space of the delivery. So now 420 ml of the oxygen is delivered as per 20 breaths. So 420 divided by 20, that is nearly 21 ml per breath at the purity of 90. So if we calculate it, it is also same 19 ml of oxygen is delivered per breath by the portable oxygen concentrator, which is equal to the oxygen utilized by the patient in the stationary oxygen concentrator at the same setting. Now we are talking about the pulse mode machines. So they are also coming in 2 variants. One is the fixed per breath dose delivering machine, and other are the fixed per minute dose delivering machines. So in the fixed breath dose machines, we see ox-life independence by O2 concepts, which delivers fixed dose of oxygen per breath. If we see at setting of 2, it delivers nearly 32 ml of oxygen per breath, but it is fixed. It cannot change if the patient breath rate is changed. In case of fixed per minute delivery machine, that is Inogen, it delivers 420 ml of oxygen at the setting of 2. So that I have already told. So if the patient is taking 20 breaths per minute, then it is delivering 21 ml per breath. If the patient is taking 10 breaths, then it is doubled. It comes to the 42 ml per breath that it can deliver to the patient. So it matters if the patient blood rate changes. So if we talk about the pulse port machines in the market, so there are various machines: Airsep, Focus, Freestyle 3, Freestyle 5, Eclipse, Inogen 1, G3, Inogen 1 G4, Inogen 1 G5, Philips Minigo, David based machines is also there, InvaCare XPO2. So now coming on to the some benefits or the limitations of the pulse flow machine. So benefits, we can say it is easy to use, small in size and lightweight, low noise level, multiple power operating options. It can be operated by AC, DC or battery. So it gives the freedom to the patient to move on. You can walk in the park or can travel in the airways or the car using that machine. So there are some limitations also. It is little uh, expensive machine, not sufficient for the patients who need more than 4 or 5 liters per minute or maybe needing high pressure machines. So the patient who takes very short breaths, shortened breath patient, they are not comfortable with these machines. Thank you.
Thank you very much, Kuwinda, for that topic. It was very interesting and informative. I think it would be a good thing if we had this post-flow thing across all versions of Concentrator. But as you pointed out, one of the limitation is the expense. So probably it will make everything more expensive if it spans across all the models. But yeah, thank you very much for that topic. If we have some questions from the audience on the topic that Kuwinda has just presented to us, we are free to ask those questions or make those further comments if we have them. All right, seems we do not have any comments there. So we'll now get back to our questions and move on with the session. So our next question says, I have an Oxyflow 5 that has a low oxygen purity in our workshop. As a repair procedure, I removed the cover and found the unit filled with white powder. I traced and found that it was coming from the sieve beds. I then replaced the sieve beds and blew out the powder of the valve and cleaned out the zeolite that was inside the machine and the tubes. After all this, the purity remains at 40%. What can be the cause? So I will ask Masofa to respond to this one.
Thank you, Moabi. The white powder you found in the machine is contaminated zeolite. Contamination of the zeolite material happens when moisture gets into the sieve beds and breaks down the zeolite granules and turns it into fine white powder. When the zeolite gets contaminated, it gets discharged out of the beds into the muffler exhaust through the pneumatic valve. If the powder discharge is not detected earlier, it leads to disruption of the valve operation and could also clog the exhaust. In your case, where the valve and the sieve beds were replaced, the problem might be in the clogged exhaust, which can be detected by the or no exhaust sound. When this part is clogged, it prevents the nitrogen from being released. This now means that the nitrogen remains in the system, and which will then lead to low oxygen concentration. Yes, yes, that you need to do to solve the problem. You will need to open the exhaust canister as shown in the picture. That is the exhaust canister. And then you will need to take out the sponge and clean. Also, disassemble the part with a tube that pours. Remove the zeolite and then in that tube and unblock all the pores clogged by the zeolite. Once this is done, the machine should be able to produce good oxygen levels. Thank you.
Thank you very much, Masofa, for that explanation. I hope that was clear for all of us. But in case we have some questions, we are always free to ask those questions. All right, it seems we do not have any questions.
Just a
so
comment.
We'll now move on to our next question. So our next question says, we have an OxyPure machine. Yes, Tato.
Yeah, so I just wanted to comment out that people might be wondering, like, how do you blow out the zeolite that was blocking in the hose? So I think one of the best way to do that is maybe using compressed air, because it's powerful enough to do the job. Of course, people might prefer using the blower as well, but I feel like a compressor would do a very good job here. Yeah.
Okay, thank you very much, Tato, for those additional comments. Yeah, it's true. The air compressor works pretty well, but yeah, the leaf blower will do the job also. All right, so the next question says, we have an OxyPure oxygen machine at our facility that works well when being used at 3 to 5 liters per minute, but alarms and gives a low flow error when it is run at 1 to 2 liters per minute. What can be the cause of this? So I will ask Effa to respond to this one.
Once again, thank you, Maui. That sounds like a sensor failure issue. As we know, oxygen concentrators have sensors installed in them to help enhance their performance and to detect failures within the concentrator. At the end of oxygen generation system in a concentrator, just before the oxygen is delivered to the patient, there is a sensor, mostly a ultrasonic sensor. As you can see in the slide, that's the ultrasonic sensor. The function of this sensor is to monitor and measure the oxygen concentration of the air delivered to the patient. And it also measures the flow at which the oxygen is being delivered. Since your concentrator is showing a low flow error, it means the sensor is not detecting the oxygen flow at a low flow meter setting. You need to replace the sensor to solve this problem. When replacing the sensor, also look at the cable to check for any visible wear or tear. If there is any visible wear or tear, please replace it. Thank you, Maui.
Thank you very much, Effa, for that explanation. I hope we all understood it and got the solution that she suggested. But in case we have some further comments or questions that we'd like to make, we are always welcome to make those comments. Right, it seems we don't have any questions there. So now we'll move on to our final question of the day. So our question says, I have been repeatedly working on the same oxygen concentrator from the ward. Upon troubleshooting during both occasions, I always find that the new step-down transformer I previously replaced is burnt. What could be the root cause of such burns and the solution as well? So I will ask Paulina to.
Thank you, Mwabi, for the question. This part is so important for your machine to work perfectly. This part lowers the electrical supplied voltage to recommended voltage needed by the printed circuit board, which is the PC board. Main cause of such repeated bends is the frequent or recurring voltage fluctuation. Every electrical appliance is designed to work under different levels of voltages. If the electric voltage is not stable and frequently exceeds the recommended voltage rating, this may result in damaging the oxygen concentrator step-down transformer or the whole circuit board. It is advisable to make sure that electric voltage is stable whenever using the oxygen concentrator. A voltage stabilizer is ideal for solving such problems. The stabilizer helps in making sure that the gadget is receiving the recommended power rating. This will help in making sure that the machine works longer without any breakdowns. Thank you.
Thank you very much, Paulina, for that answer. I hope that was very helpful, and I hope we got the solutions that we're looking for. So one thing that I've seen happening now is most of the DVBs 525 concentrators are coming with these voltage stabilizers, so which is a good thing. So once you buy the unit, it comes attached with the voltage stabilizer. So, but then if you don't have the voltage stabilizer, then you need to purchase that as a separate unit. Right, so if we have some questions or further comments on this question, we are free to make those comments or ask those questions if we have any. I see we have a hand. Go ahead, Nteto.
Yeah, a last comment from me. So, like on the transformers, I think it's always good to pay attention to because normally transformer will have, let's say, 220 volts input, and then it steps down to like maybe 12 volts, 24 volts. So it's always good to pay attention when you're working with transformers as well when they are bent, so that if the machine requires like a 12 volts VSC, don't give it a 24 volts VSC because you might bend components there. Yeah, that's the comment I had, Mark. Thanks.
Thank you very much for that additional comments. Yeah, it is indeed very important to pay attention to those small details. Otherwise, then you will just end up ruining your unit. So reaching this far, this now brings us to the end of our session today, and I would like to thank you all for joining us for today's call. I saw we had a couple of new faces, so please share with us your email address and also just tell us where you joined from so that we can add you to our mailing list, and then that will help us to keep sending you updates from the Oxygen Alliance, as well as reminders about the Oxygen Concentrator Talk course. So in case you missed some of our previous sessions, we always record all our sessions and then we upload them on our YouTube channel. So if you just search for Oxygen Alliance, and you will be able to get to all the previous sessions that we have had. So once you get to the YouTube channel, please don't forget to subscribe and share the videos with your friends and colleagues as well. We also have a website which is also a great resource. We also have a lot of information on the website. So if you have some of these issues, you can visit our website. Tato, if you would please post the link in the chat. So if you can't find a solution on our website, then you can always contact us through our email address. So reaching this far, I'd like to wish you a great week, and we will see you again in our next Concentrator Talk call. Goodbye.